Okay, dear students, let's try to understand the application of dimensions. There are more uses, but today we'll try to learn one of the use, and that use is to check, the correctness of formula. To check the correctness of formula, any formula equation given to you, we can check its correctness. Okay, so to begin with, first one we'll take simplest one, that is v is equal to u plus at. Right, now you see that v is your final velocity, okay, whereby your u is nothing but it is called as initial velocity, and definitely, as you know very well, is acceleration, and t is time. Okay, this you must know very well. Okay, so u and v both are the velocities. So let's try to prove this. We'll take first left hand side. In left hand side we have v. This is left hand side, this is right hand side. What is v? Is velocity. You know velocity can give displacement upon time, which is how we write L by T. So we can write this as m L T. Okay, so there's no mass here, so we write 0. L is 1, so we write 1, and time is a denominator. We'll take up this become 1, so it become minus 1. Okay, so this you can write as one equation number 1, 2. Let's go for the right hand side. Okay, if you see the right hand side, you have two parts, that is u plus at. Okay, now so this is the u is also a velocity, so its dimension will be same thing as like velocity, so we can write m0 l1 and t raised to minus 1. Okay, what about acceleration? So you know that acceleration we define how velocity upon time, or rather change velocity upon time. Okay, and velocity is written as displacement upon time. Just now you have done this L by, and this is already one t here, we write t, so you get L by e square, which will turn out to be a dimension in the form of turn out to be m l t. So L is 1, so we write 1. There's no mass, we write 0, and since this 2 is in denominator, t raised to power 2, when take up this become minus 2. Okay, and the one more is we have is the time t, which we write t. So as we know very well, this is m l and t. No mass 0, no length 0, only time is only 1, so we write t raised to 1. Okay, so this all will put into the whatever we have used this now. Okay, this all part will put into this your right hand side. Okay, let's try. Therefore you get right hand side is equal to u plus at. So you get u is already find the dimension as this, that is m0 l1 t raised to minus 1 plus your dimension of acceleration is nothing but we get this. Okay, acceleration is this, we'll put this here m0 l1 t raised to minus 2 into what do we have, t, time t, dimension of time is this, we already found out. So m0 l0 t raised to 1. Okay, now here there's no problem, but you see there's a multiplied, so we have to solve this somehow. So we write m0 l1 t raised to minus 1. Okay, when I'm doing this, you see when you multiply m to m, what do you get? m0 plus 0 becomes 0 only, so we get m is equal to 0. Again you're going to multiply length to length, that is here there's a power 1 and there's power 0, say 1 plus 0 will give you l1, whereas here you see t raised to minus 2, and here you have plus 1, minus 2, okay, plus 1 will give you minus 1, right? So this minus 1 will reflect here as minus 1. So this is, you can write equation number 2. So this becomes your left hand side. If you see the left hand side, right hand side, sorry, this is right hand side. So if you see the left hand side and right hand side, you see this m0 l1 t raised to minus 1, here also you get m0 l1. So you see both left hand side and right hand side dimensions are perfectly matching, that is left hand side is equal to right hand side. In such cases we'll say that, what we'll say, the given equation is dimensionally, you have to use this word dimensionally, dimensionally correct. Okay, so this is how we find the dimension of this is using dimension we prove that correctness of formula. So we have concluded that this is dimensionally correct. Okay, so dear students, those above equation can also be written like v is equal to e plus at, can also be written as v minus u is equal to at, or it can also be modified at a is equal to v minus ut, etc. In either cases, this and this are the same. Either cases you can prove such dimensions. Okay, let's continue. We'll take another equation. Our simplest equation we can take as v square minus u square is equal to 2as, okay, which can also be written like v square is equal to u square plus 2as, okay. So we'll follow right now this one, so we can use either way, but you have to show dimension left hand side, right hand side, otherwise everything remains same, okay. Let's continue, okay. So this is v velocity, as you know that. What is the dimension of velocity? Is the distance upon time, which you already found out, distance. So m0, distance is n, upon time is the denominator, so we write -1. But since it's a v square, okay, since it's a v square, this also become square, okay, which you can rewrite, or just as simple we can write as, so 2 into 0 becomes 0, 1 into become 2, and -1, this -1 into 2 become raised to -2, as simple as it, okay. So then we can find u square. So what u is also initial velocity, so your dimension of initial velocity will be very simple, that is squaring this will give same thing as m0 L2 t raised to -2. This becomes your left hand side, right? Now we have right hand side, we have 2as, okay. So we'll try to find dimension of 2as, or rather you can write left hand side dimensions are, okay, how? V square minus u square is equal to, you get m0, okay, this L2 and t raised to -2, okay, minus this u square will come here from this formula, so which is same thing as m raised to 0, okay, m raised to 0 L raised to 2 t raised to -2. This you can write as equation number 1, okay. Then right hand side, if you take, what you will get? Right hand side is given by nothing but 2as, okay. This is very simple, okay. 2 into, okay, the acceleration can be given by velocity upon time, right? Or you could find a dimension separately and come back, that also can be done, into, and your displacement given as L. If you want to find dimension separately, it could have been like this, okay. The dimension of acceleration is L by t square. L by t square means the one L remain L here, okay, L by this, okay, L by t square, so m will be 0, then no, but L will remain 1, t square means below it, so it become -2, as we did earlier, into your simple dimension of L, okay, that is m L t. Now if L is only 1, so we write this is 0, 1, and this is 0, okay. If you multiply now this, okay, if you multiply this to this, 2 is a constant, nothing to do with that, so 0 into 0 become 0 only, 1 into 1 become 2, 1 plus 1, and -2, okay, and this is 0, -2 plus 0 will become nothing but t raised to -2 only, okay. This you can write equation number 2. If you see the left hand side and right hand side, you can see here, this is your left hand side and this is your right hand side, that is this plus this and this. If you see this blue circle, all three blue circles are same, okay, all three blue circles are same. Since they are same, you can definitely say left hand side is equal to right hand side, therefore the given equations are, you can write this as this one, that is the given equation dimensionally correct, okay. So this is how we can find the next dimension also. Let's try to find out the next dimension, that is the simplest or rather dimension saying, it will nice to prove that the given dimensional equation, that is given by s is equal to ut plus half at square, okay. Again this is very simple. Left hand side, if you see, it is a displacement, this is initial velocity, this is the time, this is acceleration, and this is time square, okay. We can find dimension in steps, or you can do directly. Now since this is s, left hand side is a displacement L, so L means displacement, S means this, S means same thing as your length L, so dimension is very simple. You get m0 L1 because there's 1 and there's no time, so you write 0, okay. So this becomes your left hand side, okay. We can write equation 1. If you're going to find, for trying for the right hand side, you see you have u, your initial, this velocity will be nothing but m L t. What is the displacement upon time, right? Distance upon time, displacement time. So there's no mass involved, 1, and this, since the time denominator, it is -1. Similarly, if you try to find dimension of acceleration, acceleration is nothing but v upon t. Since v is you can write as displacement upon time, because already one more t here is become L by t square. So your dimension will be nothing but now m L t. So m is 0 because there's no mass. So you get this as t square. So L is 1, and since the t is denominator, goes as -2. Okay. So okay, t, and there also we have one more something called as time t, okay, time t. So we get time, as you know, already the dimension of time is mlt, no m0, no t, but there is the t, so we write 1, okay. But since it's a t square, okay, so this we get square, and finally we get this is equal to t square, okay, this is square. So continue with this understanding. So we'll go for left hand side, we already found. Let's try to find out the right hand side in quick way. So you have ut plus half a t square, okay. So with this understanding, what is the dimension velocity you already found? You can see from the this, it is m0 L1 t raised to -1, t raised to -1. into time t. As you know that dimension of t is nothing but very simple, m0, l0 and t raised to minus plus 1 plus half time. Okay, half time a. What is acceleration? You know this is the acceleration. So m0, l1, t raised to minus 2. Then what we have? This is t, but not t but t square. So we'll use this t square like a dimension of time only, m0, l0. Since it's square, we'll write this square. Okay, so combining all this, you get, so m0 into 0, you get m0, l1 into 0. So 1 plus 0 will give l1, t raised to minus 1 and plus 1, you get t raised to 0. Okay, this plus 1 and this one cancels, plus half time. Okay, half time. Same thing here, 0 multiplied by 0, that is 0 plus 0 becomes 0. 1 plus 0 of L become 1 only, where t minus 2 and plus 2 become t raised to 0. Okay, with this, if you see this is equation number 2, just have an eye on this. This that is reflect to your a and t square, and your this left hand side s. Okay, if you see this refer to this part, this refer this part, and this will go for this. All are same, you can see. Therefore, if you say left hand side is equal to right hand side, therefore the given, we'll write given equation is dimensionally correct. Okay, this is how put is the dimensionally correct. We'll try one more dimensions, that is say if I given sometime equation like kinetic energy is equal to half m v square. So what I'm going to do this? Okay, very simple. The left hand has kinetic energy. You must know that energy same thing as any other energy, potential energy, and this energy will have the same dimension as like work. So kinetic energy and work done both will have the same dimensions. Okay, so considering this, left hand side will be nothing but kinetic energy, which is same thing as work done. And you know that you already defined last time, the work done is given by nothing but force into displacement. Force means F and the S is a displacement. Again the force is given as mass into acceleration, and this S continues. Thus mass remain as it is m, and but acceleration will be nothing velocity upon time into this become a displacement nothing but L, which will continue as m. Okay, what is velocity? It is displacement upon time, but there's already one more t, you get multiplied by t, and this L. Okay, with combining all this, you get very simplest dimension. What is that? You see m1, so 1, L into L you get L2, t into t become t square, but when take it up that will become minus 2. So this is the dimension of the energy. We'll write equation number 2, which is as good as the left hand side. Let's try for right hand side. So in right hand side we have half m v square. Okay, half remain out, is a constant, nothing to worry about it. What is the dimension of mass? It's very simple, because there's one mass we write m, there's no L, 0, there's no t, we write 0, multiply by v. What is the dimension of velocity? It is L by t, that is m, okay, 0, L by t. Okay, now since this is square, okay, so square, so L1 and T1, in fact the t raised to minus 1, right? Now since the square, this will become 2 times, this will become minus 2. Okay, so I'll rewrite here. Okay, so 2, this is 2 and this is your minus 2. Now you see, if we multiply this m to m, 1 plus 1 will get m is equal to 1 only, 0 plus 1, 0 plus 2 will give you 2, where t raised to 0 and this become t raised to minus 2. So this is your equation number 2. If you see now, okay, if you see now, you'll find that the left hand side, dimension left hand side and right hand side are they same? Let's check. m1, l2, l2 here, t raised to minus 2, t minus 2. Wow, perfect. So we say, of course there is half to be written here, because there's constant has no dimension, so it continues as it is. So we say very simple way, that is left hand side is equal to right hand side, and you have to make one sentence, that is the given equation is dimensionally correct. Okay, I hope you have understood everything perfectly nicely. We'll meet next time for something very new. Thank you.